Hi, in this video we're going to study the integral of cosine 3x times cosine of 6x, and as we will see, there is more than one way to compute that integral. Now I want to share with you two ways, and I'm pretty sure there are many more. So if you find any other way, please comment on the video and let me know. I would be interested in learning about other ways. But I wanted to share with you the following two ways. So one way will come from using a trigonometric identity in order to rewrite the cosine of 3x times the cosine of 6x in terms of the cosine of 9x and the cosine of minus 3x. And we will get to use this formula. That way we will turn the integral into something a lot simpler, and we use substitution once to find the integrals we end up with. The other way also requires us to use trigonometric identities. In particular, notice that we have the cosine of an angle times the cosine of the angle doubled. And what happens is that the cosine of the angle doubled is related to the sine of the angle in the following way. We can prove that the cosine of twice an angle is 1 minus twice sine squared of the angle. And by using that trigonometric identity, we will reduce the integral to computing the integral of something simpler, and again we will get to use substitution, although more times. Or, well, we can just do it all at once, but it's a different substitution. Now, you may be wondering about why we don't use integration by parts. Well, it turns out that if we try to apply integration by parts, we will find that the integral of cosine times cosine is in terms of the integral of sine times sine, and then we can use integration by parts again to rewrite the integral of sine times sine in terms of the integral of cosine times cosine. But I invite you to check that it won't work. So it's a bit of a long exercise to check that it won't work, but it won't work. So okay. Now I'm pretty sure, as I said before, I'm certain that there are more ways of finding the integral of cosine of 3x times the cosine of 6x. But I thought that those two ways I will share with you are nice enough. But you're welcome to share what you think about this and what you think an alternative could be. Okay, so let's go with the first way. So suppose we use the fact that the product of cosines corresponds to half the cosine of a certain angle plus the cosine of another angle. So when we use that formula with alpha equals 3x and beta equals 6x, we find that the cosine of 3x times the cosine of 6x equals a half of the cosine of 3x plus 6x, that's 9x, plus the cosine of 3x minus 6x, and that's minus 3x. And we have that cosine is an even function. So the cosine of an angle is the same as the cosine of minus the angle. So we can replace minus 3x by 3x. This way. Okay, so we have the integral of cosine of 3x times the cosine of 6x, by using this trigonometric identity, we can reduce this integral to finding the integral of a half of a cosine of 9x plus a cosine of 3x. And then we know that we can pull constants out of integrals. So here we have a half of the integral of cosine of 9x plus a cosine of 3x. And we can also distribute integrals. The integral of the sum is the sum of the integrals. So we actually have a half of the integral of cosine of 9x plus the integral of the cosine of 3x. Okay, now we have integrals that are a lot simpler. Here we almost have the integral of cosine, and we know that would be a sine. But the angle is not exactly x, but 9x, so let's use substitution in order to find the first integral. And we would do something similar to find the second integral. So if we took u equals 9x, then du would be 9dx. Or same thing, dx is a ninth of du. So we will have the integral of the cosine of u times 1/9 of du. And we can pull the 1/9 out to get the integral, get 1/9 times the integral of cosine, and that's a sine. So we would end up with the sine of u, and that's 9x divided by 9. Similarly, the integral of the cosine of 3x will be a sine, but divided by 3. So we have that the integral we were given equals to 1/2 of sine of 9x over 9 plus sine of 3x over 9, over 3, because this time we have 3 times x. And then we add a constant, because every time we find an indefinite integral, we add an arbitrary constancy. So the final answer would be 1/18 of the sine of 9x plus 1/6 of the sine of 3x plus a constant. Okay, so this is one way, and we end up with an 1/18 of sine of 9x plus a 1/6 of sine of 3x plus a constant. Let's check the other way. The other way I want to share with you. And as I said before, I know there are many more ways. So let's see. So another way will come from using the fact that the cosine of twice an angle relates to the sine of the angle. This way we will have 1 minus twice sine squared of the angle. So we can take alpha equal to 3x, and we have that the cosine of 6x is equivalent to 1 minus twice the sine of 3x squared. That way, the integral of cosine of 3x times cosine of 6x is the same as the integral of cosine of 3x times, here we have a bracket, we insert 1 minus, oops, there you go, 1 minus twice the sine squared of 3x into the integral where we had cosine of 6x. And now we distribute the cosine to have to get the cosine of 3x, take away, and then we have twice sine squared 3x times the cosine of 3x. Just rearrange the expression a bit, and here we have we can distribute the integral, because the integral of a subtraction is the subtraction of integrals. So we have the integral of cosine of 3x, take away, and we can pull constants out just as we did before. We have a 2 integral of sine squared times sine squared of 3x times cosine of 3x dx. Okay, now to find the integral of cosine of 3x, we use substitution the same way we did before, and we find the sine of 3x over 3. So that part works same way it did before. Now to find the integral of sine squared of 3x times cosine of 3x, we can use substitution again, but this time the substitution will be different. We have something with sine and cosine, and if we thought of the integrand as a function of sine, then we would have the integral of u squared times something that is very similar to du, because du would be 3 cosine of 3x. So we get that cosine of 3x times dx corresponds to du over 3. So here we have du over 3. The 1/3 can be pulled out, and we can use a power rule in order to say that this will be 1 divided by 3 u cubed over 3. And again, we have a constant. We could have added a constant here too. They don't have to coincide. And then so here we will have 1/3 times 1/3 of u cubed. That's 1/9. U cubed corresponds to sine cubed of 3x, and then we add a constant. So it got a bit crumped up here. Let me just ignore constants for now, because we can just gather them into one single constant. So we have those integrals right there up to a constant, and I wanted to move this over here. Okay, so we have that the integral we are trying to find, the integral we wanted to find corresponds to the following one. So we have 1/3 of sine of 3x plus 1/9 of the sine cubed of 3x, and then we add constants to get just an arbitrary constant. We can call it c, and that would be it. Now you might be wondering why this function looks different from the one we got as the answer before. And what happens is that it's equivalent expressions. We can rewrite one of them in terms of the other. We can rewrite one of them as the other plus a constant by using trigonometric identities. So it's really the same answer up to a constant. Okay, that's it for this video. And if you have questions, please comment on the video and contact me so that I can try to help. And again, if you have some more alternatives to computing this integral, then please share, and it would be great to get to know more ways. Okay, bye bye.